This is a 2016 AP problem number 2. We're going to do this one together because it's a little bit different. It gives us dx dt like it usually does, but then it gives us a graph here of y of t. It doesn't give us dy dt as an equation or as a graph. So part A asks us for the particle's position at t equals 3. This was a calculator problem. So we can find the x value of position the same way we did in class last time. Get rid of all this stuff. So we want to graph dx dt. We know where the particle is at time 0. We're looking for where it is at time 3. So we want to integrate dx dt starting at time 0 and ending at time 3. Gives us this, plus its initial position of 5. Tells us that it ends at 14.377. So the x value of that coordinate is 14.377. Probably should show some work on that. The y value, this is a graph of y of t. So we want the time at time 3. We want where it is at time 3. At time 3 is this point right here, and this is a graph of y of t. The slope of this line is exactly 1/2. So this point is negative 1/2. That is the y value. Part B wants the slope of the line tangent to the path at t equals 3. So it wants dy dx. dy dx, remember, is dy dt divided by dx dt. dy dt, this graph is y. The graph is not dy dt. So dy dt would be the slope of this line at time 3. Slope of the line is 1/2. Dx dt at time 3, we're just going to plug 3 into this equation to get dx dt at time 3. You can either plug it into the equation or you can look at your table. At time 3, that equation, which is this equation here, dx dt is equal to 9.95637. And then divide. Gives us 0.050. Part C wants the speed of the particle at t equals 3. Speed is equal to the square root of dx dt squared plus dy dt squared. And we want it at time 3. So dx dt at time 3 was this 9.95637. And dy dt at time 3 is 1/2. And then it's calculator time. For part C, I get 9.969. And finally, part D wants the total distance traveled by the particle from time 0 to time 2. So total distance traveled is the integral of speed. So we want to integrate from 0 to 2 the square root of dx dt squared plus dy dt squared. If it asked from 2 to 4, we would just use 1/2 for dy dt, because from 2 to 4, dy dt is always 1/2. The problem is it asks from 0 to 2, and dy dt isn't consistent from 0 to 2. Dy dt for part of it is this, and then part of it is this. So we're actually going to have to split this up into two separate integrals. We are going to do the square root of dx dt squared plus dy dt squared from 0 to 1. From 0 to 1, dy dt is the slope of this line, which is -2. That didn't help much. And then we need to do the same thing for the integral from 1 to 2 of the square root of dx dt squared plus dy dt. Dy dt would be the slope of this line from 1 to 2, which is 0. So we are going to be integrating, so we need to graph it, the square root of dx dt, which is y1, plus -2 squared and we only want to graph y2, we don't want to graph y1, so turn that graph off. Now we can do it. We are graphing this from, or integrating this from 0 to 1, which gives us 2.2379. We want to do the same thing, but dy dt is 0 and integrate from 1 to 2. And then add them together. (2.1120) plus the one we had before, 2.2379. Gives us a total distance traveled of 4.350 units. So again, the reason we needed to split that one up is because dy dt was not the same thing on the entire interval from 0 to 2. It follows two functions, this function for a little bit and then this function for a little bit.